Welcome to the video lectures on the course Database Management Systems 3 CS 3492 Unit 4 Implementation Techniques. The topic for the discussion is RAID. Now let us know what is the need for RAID. The data storage requirements of some applications have been growing so fast that a large number of disks are needed to store data for such applications, even though disk drive capacities have been growing so fast. To improve the reliability of data storage, the information are stored redundantly on multiple disks. So, the failure of one disk does not lead to loss of data. A variety of disk organization techniques, that is called redundant array of independent disk, that is RAID, have been proposed to achieve the reliability and improved performance. The I in RAID stands for independent, but originally it stood for inexpensive. Improvement of reliability via redundancy. The solution to the problem of reliability is to introduce redundancy. That is, we store extra information that is not needed normally, but that can be used in the event of failure of a disk to rebuild the lost information. Thus, even if a disk fails, data are not lost. The simplest approach to introduce redundancy is to duplicate every disk, but it is most expensive. This technique is called as mirroring or shadowing. The mean time to failure of a mirror disk depends on the mean time to failure of the individual disk, as well as on the mean time to repair, which is the time it takes to replace a failed disk and to restore the data on it. Storing the same data in different disks increases the fault tolerance. Next, the improvement in performance via parallelism. To improve the now let us consider the benefit of parallel access on multiple disks. With the disk mirroring, the rate at which read request can be handled is doubled, since read request can be sent to either disks. With multiple disks, we can improve the transfer rate as well by striping the data across the multiple disks. Data striping consists of splitting the bits of each byte across multiple disks. Such striping is called as bit level striping. Next one is block level striping. It stripes blocks across multiple disks. It treats the array of disks as a single large disk, and it gives blocks with logical numbers. There are two main goals of parallelism in the disk system, that is load balance multiple small accesses, that is block accesses, so that the throughput of such accesses increases, and parallelize large access so that the response time of large access is reduced. Next, we move on to RAID levels. Now, let us see what is RAID. Already I said that RAID is a redundant array of independent disks. It is a setup consisting of multiple disks for data storage. They are linked together to prevent the data loss, and it will speed up the performance. There are different levels in RAID. First, we move on to RAID level 0, that is block striping, non redundant. Um, this level maintains no redundant data and so has the best write performance since updates do not have to be replicated. Data striping is performed at the level of blocks. It is used in high performance applications where data loss is not critical. In RAID level 0, it refers to disk of arrays with striping at the level of blocks but without any redundancy. That is such as mirroring or parity bits. Next, RAID level 1, it is mirror disk with block striping. In RAID 1, it is an array consisting of at least two disks where the same data is stored on each to ensure redundancy. The most common use of RAID 1 is setting up a mirrored pair consisting of two disks in which contents of the first disk is mirrored in the second. This is why such a configuration is called as mirroring. In RAID 0, where we focus on the speed and performance, but in the primary goal of RAID 1 is to provide redundancy. It eliminates the possibility of data loss and downtime by replacing a failed drive with its replica. In such a setup in RAID 1, the array volume is as big as the smallest disk and operates as long as one drive is operational. Apart from reliability, mirroring enhances read performance as a request can be handled by any of the drives in the array. On the other hand, the write performance remains the same as with one disk and is equal to the slowest disk in the configuration. It increases the read performance and it provides redundancy and fault tolerance, and it is very simple to configure and easy to use. But but the disadvantages of RAID 1 is uses only half of the storage capacity, more expensive, needs twice as many drivers, um, requires powering down the computer to replace failed drive. Next, the RAID level 2. It is bit level striping with the Hamming code parity, that is memory style error correcting codes with bit striping. RAID 2 is rarely used in practice today. It combines bit level striping with error checking and information correction. This RAID implementation requires two groups of disks, one for writing the data and another for writing error correction codes. RAID 2 also requires a special controller for the synchronized spinning of all disks. Instead of data blocks, RAID 2 stripes data at the bit level across multiple disks, and it uses the Hamming error code correction um, and stores the information on the redundancy disk. The array calculates the error code correction while writing the data. It stripes it to the data disk and writes the code to the redundancy disk, as well as while reading data from the disk, it reads from the redundancy disk to verify the data and make correction if needed. The advantages of RAID 2 is it is very reliable and it has the ability to correct stored information. And the disadvantage is it is very expensive and it is difficult to implement and requires entire disk for error correcting code. RAID 3 is bit interleaved parity. Like RAID 2, RAID 3 is rarely used in practice. This RAID implementation utilizes bit level striping and a dedicated parity disk. Because of this, it requires at least three drives, where two are used for storing data stripes and one is used for parity. RAID 3 also needs a special controller due to its configuration and synchronized disk spinning. Um, it achieves better performance rates with random read write operations. The advantages of RAID 3 is good throughput when transferring large amounts of data, then high efficiency, uh, and disk failure. Uh, High efficiency with the sequential operations. And the disadvantages of RAID 3 is it is not suitable for transferring small files, and it is very complex to implement, and it is difficult to set up a software RAID. Next, RAID 4, RAID level 4, that is block interleaved parity. Um, in this level, mm, it consists of block level data striping across two or more independent disks and a dedicated parity disk. The implementation requires at least three disks, two for storing data stripes and one dedicated for storing parity and providing redundancy. As each disk is independent and there is no synchronized spinning, there is no need for a controller. RAID 4 configuration is a bottleneck when storing parity bits for each data block on a single drive, and it impact on system performance. The advantages of RAID level 4 is fast read operations, low storage overhead, and simultaneous IO requests. The disadvantages: slow write performance, redundancy is lost if the parity disk fails, and bottleneck that having big effect on overall performance. Next, we move on to RAID level 5. It is a block interleaved distributed parity. RAID 5 is considered as the most secure and most common RAID implementation. It combines mm, it combines striping and parity to provide a reliable setup. Such configuration gives the user storage usability with RAID 1 and the performance efficiency of RAID 0. Um, this RAID level consists of at least three hard drives. Data is divided into data stripes and distributed across different disks in the array. This allows for high performance rates due to fast read data transactions, which can be done simultaneously by different drives in the array. Parity bits are distributed evenly on all the disks after each sequence of data has been saved. Um, this feature ensures that we still have access to the data from parity bits in case of a failed drive. Therefore, RAID 5 provides redundancy through the parity bits instead of mirroring. The advantages of RAID 5 is high performance and capacity, fast and reliable, uh, RAID operation tolerates single drive failure, and the disadvantages, longer rebuild time, more complex to implement. If more than one disk fails, data will be lost. These are the disadvantages of RAID 5. And in next one is RAID level 6. It is a P plus Q redundancy scheme, or it is called as striping with double parity. RAID 6 is an array similar to RAID 5 with an addition of its double parity feature. For this reason, it is also referred to as the double parity RAID. This setup requires a minimum of 4 drives. The setup resembles RAID 5 but includes 2 additional parity blocks distributed across the disk. Therefore, it uses block level striping to distribute the data across the array and stores 2 parity blocks for each data block. This block level striping with the 2 parity blocks allows um, you to 2 disk failures before any data is lost. This means that this means that in an event where 2 disks fail, RAID can still reconstruct the record data. Its performance depends on how the array is implemented, as well as the total number of drives. Write operations are slower compared to the configuration due to its double parity feature. The advantages of RAID 6 is high fault and drive failure tolerance, storage efficiency, fast read operations. And the disadvantages is rebuild time can take up to 24 hours, slow write performance, and it is complex to implement and more expensive. These are the levels of RAID. Next, the choice of RAID level. Choice of RAID level. Performance is increased through data striping. The data is segmented into equal size partitions which are transparently distributed across multiple disks. And we know that striping improves overall IO performance by allowing multiple IOs to be serviced in parallel. At the same time, data striping also balances the load among the disks. For example, Oracle recommends use of RAID 1 for the redo log files, and for the database files, Oracle recommends either RAID 5 provided the write overhead is acceptable. Otherwise, uh, Oracle recommends a RAID 1 or 0 plus 1. So, RAID 6 is a good solution for mission critical applications where data loss cannot be tolerated. But RAID 5 often used for file and application servers because of its high efficiency and optimized storage, and it is the best cost effective solution if continuous data access is a priority and we require installing an operating system on the array. So level 6 is rarely used since level 1 and 5 offer adequate safety for almost all applications. So level 5 is preferred for applications with low update rate and large amount of data. Level 1 is preferred for all other applications. Next one is hardware issues. There are different ways of utilizing the data. utilizing the RAID, differing by where the processing takes place. Software RAID and hardware based RAID. The software based RAID, for the software setup, we should connect the drives directly to the computer without using a RAID controller. In this case, we want to manage the disk through utility software on the operating system. There is no special hardware support. In hardware based RAID, when installing the hardware setup, we have to insert a RAID controller card in a fast PCI Express slot on the motherboard and connect it to the drives. External RAID drive enclosures with the um, built-in controller card are also available. It uses a non-volatile RAM to record writes that are being executed. So these are the hardware issues in software RAID and hardware RAID. And the other um, and some hardware RAID implementations permit hot swapping. Uh, that is, faulty disk can be removed and replaced by new ones without turning power off. Hot swapping reduces the mean time to repair since replacement of a disk does not have to wait until a time when the system can be shut down. This is called hot swapping, and this is up to RAID. Thank you.